Greetings and welcome to this series of lectures on systems of equations, 4.3 Applications Using System of Equations. When you're working with application problems, I think the hardest thing is, first of all, deciphering what the problem is asking for, what information you're given, and how the heck do I conquer this problem? Well, let's look at a strategy that you can use. First thing, well, you've got to read the problem. You got to figure out the given information which is relevant and what are the unknowns. I mean, what are you looking for? Second is we generally assign variables to our unknowns like x for the first unknown, y for the second unknown, z for the third unknown if you need it. Okay. Then you need to translate all the other known information with the unknown information into an expression. At this point, you want to reread the problem. Why? Because what if you missed something, or what if you grabbed information that was irrelevant, right? In 1945, the World Series, blah, 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 blah. I didn't need 1945, but it was a number, and sometimes that gets me distracted. So make sure you reread the problem and see if you missed anything, see if you grabbed anything that you didn't need. Fourth step. Solve the system that you created in step 2. Once you have the answer, you should write your answer in a complete sentence. That will help you analyze to see if your solution that you found, if it even makes sense, right? Reread the problem. Does your answer make sense? So basically there are 6 steps in solving application problems. All right, let's look at a problem. One number is 2 more than 3 times another. Their sum is 26. So, read the problem. Okay, it looks like apparently I'm looking for 2 numbers. So, I have 2 unknowns. So, let's let one number equal x and another equal y. And if I have one number and another number, I also know that one number, x, is, that means equal, 2 more than 3 times another. 3 times another is 3y. 2 more than 3y is plus 2. So x will equal 3y plus 2. We also know their sum, meaning x and y, is 26. Therefore, x plus y equals 26. 2 unknowns, 2 equations. This is a system I can solve. Right? Since x equals 3y plus 2, I might as well use this information and substitute the 3y plus 2 into the second equation. All right, 3y plus 2 in lieu of x, plus y equals 26. Add like terms, 4y plus 2 equals 26. Subtract 2 from both sides. 4y equals 24. Divide each side by 4. Y equals 6. Well, now that we know y equals 6, we could plug it back into either one of the equations. I like the first one since it already says x equals. X equals 3 times 6 plus 2. 3 times 6 is 18. Plus 2 is 20. Therefore, the numbers are 6 and 20. And you should kind of reread the problem. 20 is 2 more than 3 times 6. Well, 3 times 6 is 18, plus 2 is 20, so that works out just fine. Maybe you don't need to go back and do math on paper, but just analyze your problem to see if indeed your answer makes sense. Suppose 850 tickets were sold for a game for a total of $1,100. If an adult ticket costs $1.50 and children's ticket costs $1, how many of each kind of tickets were sold? So I don't know how many of each kind were sold. So I'm going to say the number of tickets that I sold were adult tickets. I'm going to call that x. And therefore I'm going to let y equal the number of children's tickets. Usually the last sentence of what you're looking for is generally your x and y. I also know the amount of money I make selling adult tickets will be the number of adult tickets times $1.50. I also know the money we made on selling children's tickets was going to be the number of children's tickets times $1. Okay? Well, since the X is number of adult tickets, I know that the amount of money that I've earned on adult tickets will be $1.50 times X, and the amount of money that I earned on children's tickets will be $1 times Y. The number of tickets total were sold 850. So the number of adult tickets plus the number of children tickets will equal 850. That's going to be X plus Y equals 850. The amount of money that I made on the adult tickets plus the amount of money I made on the children's tickets will equal the total amount of money we made. So $1.50 times X plus $1 times Y equals 1,100. Okay. I'm going to go ahead and solve the first equation for X. So it says X equals 850 minus Y. And then I'm going to go ahead and substitute in X into the second equation. $1.50 times 850 minus Y plus $1 times Y equals 1,100. That's going to give me 1275 minus 1.5Y plus 1Y equals 1,100. Add like terms here. 1275 minus 0.50Y equals 1,100. Subtract 1275 from both sides. Negative 0.50y equals negative 175. Divide by negative 0.50. That gives me y equals 350. Okay. If y equals 350, I can plug it back into my original equation and solve for x. Well, I just went ahead and used the x equals 850 minus y. So if x equals 850 minus 350, x equals 50. But what does that mean? That means there were 500 adult tickets sold and 350 children's tickets sold. Okay. And then you just want to say, is that possible? Yes, it's possible. So if they were totally outlandish, I mean, we made $1,100, and if I sold 1,000,000 tickets, that wouldn't have made sense. But 500 adult tickets and 300 children tickets, that makes sense. All right, suppose a person invests a total of $10,000 in 2 accounts. One account earns 8% annually, the other account earns 9% annually. If the total interest earned from both accounts in 1 year was $860, how much was invested in each account? Well, I don't know how much was invested in each account, so I'm just going to let x equal the amount in the account earning 8% and y equal the money in the account earning 9%. That means the total amount of money that was invested was $10,000. Therefore, x plus y equals 10,000. Now I just want to recall something. How do I figure out interest? Well, interest is the amount invested times the interest rate will give us the interest earned. Okay? So the amount invested, x, times the interest rate, 8%, will equal the interest earned in that account. Likewise, the amount invested, y, times the interest rate, 9%, will give us the interest rate in that account. If I add those two together, it will add up to 860. So, we don't work with percent, we do the decimal version. 0.08x plus 0.09y equals 860. Okay. Several ways of solving it at this point. We have our system. Now we can select how we're going to solve it. Right? I'm going to go ahead and solve the first equation for x. So x will equal 10,000 minus y. Okay. I'm going to plug that into the second equation wherever I see an x. I'm going to get 0.08 times 10,000 minus y plus 0.09y equals 860. To distribute. So 0.08 times 10,000 is 800. 0.08 times negative y is negative 0.08y plus 0.09y equals 860. Combine like terms of your y's. 800 plus 0.01y equals 860. Subtract 800 from both sides, leaving you 0.01y equals 60. Nearly there, nearly there. Divide by 0.1 for both sides, leaving you y equals 6,000. Now all we need to do is plug y back into either one of these equations to solve for x. X plus 6,000 equals 10,000. Subtract 6,000 from both sides, therefore x equals 4,000. So what do those answers mean? It means $4,000 was invested at 8% and $6,000 was invested at 9% interest, right? So kind of neat that we were able to do this fairly shortly. I mean, it was a hard problem, but it was fairly short, compact. That's what I was looking for, compact. Now I want to give you a handful of examples on how you would use the system of equations here. So here's a chemistry problem. How much 20% alcohol solution and 50% alcohol solution must be mixed to get 12 gallons of 30% alcohol solution? Okay, so we know the total number of gallons has to be 12, and the ending alcohol solution must be 30%. All right, so let's let x equal the number of gallons of the 20% solution. Let's let y equal the number of gallons of the 50% solution. We know the number of gallons of the 20% solution plus the number of gallons of the 50% solution must be 12 gallons, so that's going to be x plus y equals 12. And very similar to the interest problem, the amount of gallons times the 20% will give us the amount of that solution. The number of gallons of the 50% times the 50% solution will give us the concentration of the 50% solution, and that's going to equal the 12 gallons of the 30% solution. Okay, 0.20x, number of gallons at 20%, 0.50y, number of gallons at 50%, equals number of gallons, which would be 12 of the 30%, but just to make it easier, I left the percent in front, the 30% times 12. Right? We can actually do that math. Right? I went ahead and solved the first equation for x. I'm going to plug that into the second equation. 0.20 times 12 minus y plus 0.50y equals 30.12. Let's do the math here. You get 2.4 minus 0.20y plus 0.50y equals 3.6. Combine like terms. That gives us 2.4 plus 30y plus, 0.30y equals 3.6. Subtract 2.4 from both sides, leaving us with 30y equals 1.2. That's right. Divide by 0.30, divide by 0.30, y equals 4. Now that we know what y is, we can plug it into either one of our equations, any one of our equations, and solve for x. I think this one's pretty easy, so let's go ahead and say x plus 4 equals 12. Subtract 4 from each side, x equals 8. So our answer is we need 8 gallons of the 20% solution, and we need 4 gallons of the 50% solution to obtain 12 gallons of 30% solution. Think of it like this. If you have 50% solution and you mix it with 20% solution, it's going to get diluted down, right? So you're going to get some number between 20 and 50. It's just how much of each do you need? Well, you You need 8 gallons of the 20 and 4 gallons of the 50%. All right, so where would we be without a boat problem, right? It takes 2 hours for a boat to travel 28 miles downstream, meaning if you're going downstream, you're going with the current. The same boat can travel 18 miles upstream, which is against the current, and they can do that in 3 hours. What is the speed of the boat in still water, and what is the speed of the current? Well, we have two unknowns, the speed of the boat and the speed of the current. So, let's let x be the boat speed and y be the current speed. And we need to remember that distance equals rate times time. Our upstream distance is 18, so that's going to equal the boat speed minus the current speed because it's going against it, times 3, because it took 3 hours. The downstream is going to be 28 miles, and it's going to be the boat speed plus the current because it's going downstream with the current, times 2. Well, we have two equations. 3 times x minus y equals 18, and 2 times x plus y equals 28. Distribute for both of those, we get 3x minus 3y equals 18, 2x plus 2y equals 28. That is a system of linear equations we can solve. All right, I'm just going to multiply the first equation by 2 and the second equation by -3. That will give us the result of 6x minus 6y equals 36 for the first equation, and -6x minus 6y equals -84 for the second equation. Let's add them together. 6x minus 6x is 0x's. -6y minus 6y is -12y. And 36 minus 84 is 48. Divide each side by -12. Y equals 4. Let's plug y into one of our original equations. I'll just do it in the first one. 3 times x minus 4 equals 18. Distribute, 3x minus 12 equals 18. Add 12 to both sides. 3x equals 30. Divide by 3 to both sides. X equals 10. What does that mean? Well, we let x be the boat speed and y equal the current speed. Therefore, the speed of the boat in still water is 10 miles per hour, and the speed of the current is 4 miles per hour. Okay. Just got to remember what our variables stood for in the beginning. All right, let's bump up the challenge a little bit. A coin collection consists of 14 coins with a total value of $1.35. If the coins are nickels, dimes, and quarters, and the number of nickels is 3 less than twice the number of dimes, how many of coins in each collection? Right? So we don't have just 3 unknowns. We don't have just 2 unknowns, we have 3 unknowns. Let's let x equal the number of nickels. Let's let y equal the number of dimes. And let's let z equal the number of quarters. Okay. If I have a total number of 14 coins, that means the number of nickels plus the number of dimes plus the number of quarters will equal 14. That's going to be x plus y plus z equals 14. The next has to deal with the total value of the coins, right? So we need to know the value of a nickel, the value of a dime, the value of the quarter. Once we know the value of the dime, the value of nickel and quarter, we can multiply that by the number of each, add those together, and that will get us the total value of all 14 coins. So, value of a nickel is 0.05, it's 5 cents. Dimes is 0.10 for 10 cents, and quarters is 0.25 for 25 cents. Okay, and that's all going to equal $1.35. So, value of the coin times the number of that coin I have is the total value of those coins. together, and there you have it. All right. So as it stands now, I don't have enough information to solve this system. I have 3 variables, but I only have 2 equations. But the problem did give us the number of nickels is 3 less than twice the number of dimes, right? The number of dimes is y, and twice y would be 2y. And 3 less than 2y is 2y minus 3. All of that equals the number of nickels, which is x. Therefore, x equals 2y minus 3. Okay, once again, twice the number of dimes is 2y, 3 less than that is minus 3, and all of that equaled the number of nickels, therefore it equals x. Now I have 3 equations and 3 unknowns. Now I can solve this system. Since our third equation already is set up to x equals, I'm going to go ahead and utilize, well, let's first get the first and second equation down to 1 variable. But even before I do that, I think I'm going to get rid of all those decimals. Yeah, that's what I want to do. So let's multiply the second equation by 100 all the way through. All right? That will give me 5x plus 10y plus 25z equals 135. Okay? I'm just going to call that the fourth equation. It's not really a fourth equation, it's just the second one manipulated. But you know where I'm going with that. Okay, so now let's use the first equation multiplied by negative 25, and we'll add it to the fourth equation that we created to eliminate the z. Right, that will give me negative 25x minus 25y minus 25z equals negative 350. Add that to our fourth equation. 5x plus 10y plus 25z equals 135. Add those together. I'm going to get negative 20x minus 15y, no z's, those canceled out, equals negative 215. Okay. I'm going to call that 5. Okay, that's equation 5. Well, equation 3 only has 2 variables, and equation 5 only has 2 variables. So let's use those 2, and we can solve it for y. So if I use what x equals and plug it into 5, yeah, I think that will be a little bit easier. So let's use substitution here. Take what x equals, plug it into 5, and solve for y. Right. Negative 20 times 2y minus 3 equals, my mouth is gone. Okay, negative 20 times 2y minus 3 minus 15y equals negative 215. That gives me negative 40y plus 60 minus 15y equals negative 215. Add like terms on the left-hand side. Negative 55y plus 60 minus 215 equals negative 215. Subtract 60 from both sides. 55y equals negative 275. Divide by negative 55. You get y equals 5. Okay. Now that we know what one of the variables are, let's plug that in to solve for x. I mean, we had that one where it said x equals 2y minus 3, so let's go ahead and plug that in. Y equals 5, so x will equal 2 times 5 minus 3. X equals 10 minus 3, therefore x equals 7. Now we know x, we know y. Let's solve for z. And I'm going to go ahead and take the easier one. I'll plug it into the first one where it was x plus y plus z equals 14. So 7 plus 5 plus z equals 14. That's 12 plus z equals 14. Subtract 12 from both sides. Z equals 2. But what does that mean? We don't want to just reference letters here. These are application problems. We want to answer the problem that was asked. In the coin collection, there are 7 nickels, 5 dimes, 2 quarters. That's what's system, or in the collection. Okay, ready for one more problem. In a chemistry lab, students record the temperature of water at room temperature, and they find that it's 77 degrees Fahrenheit and 25 degrees Celsius. The water is then heated until it boils, and then they take the temperature again, and the boiling water is now 212 degrees Fahrenheit and 100 degrees Celsius. Let's assume that this relationship is linear. And when I mean linear, I mean y equals mx plus b, like the equation of a line, y equals mx plus b. And I just wrote up a little table right here, the Fahrenheit and Celsius. When it was 77 Fahrenheit, it was 25 Celsius. When it was 212 Fahrenheit, it was 100 degrees Celsius. Let's let F equal X and C equal Y. Okay. If that's the case, I'm going to plug in F for X and C for Y. That's going to give me C equals MF plus B. That didn't help me much. I now have like crazy amount of variables, but I'm going to use this data over here to fill in the blanks. Remember, F equals, C equals MF plus B. C is 25 equals M times 44, or 77 equals B. Sorry, it's late. My mouth is not working. 100 equals M times 212 plus B. Now, I'm going to solve for M. I'm going to solve for B. I have two equations, two unknowns. And just to make it a little bit easier, I'm going to swap the coefficients and the variables around so it's a little bit easier to work with, at least for me. Okay, 25 equals 77M plus B is going to be our first equation. 100 times 212M plus B is our second equation. Okay. Ready? All right. Let's start using it. Well, I have a plus B and a plus B, so if I multiply one of those by -1, I can eliminate B. So let's go ahead and just do the first equation, multiply that by -1. That gives me -77M minus B equals -25. Let's combine that with the second equation of 212M plus B equals 100. That will give me 135M equals 75. Divide each side by 135. Once I reduce 75 over 135, that gives me 9/5. Therefore, M equals 9/5. Now I need to plug in 9/5 to solve for B. Right? I'm just going to plug it into the first equation. It really doesn't matter which one you plug it into. I'm just going to use the first equation. 77 times 9/5, 5/9 plus B equals 25. That's 385/9 plus B equals 25. I've got to find common denominator if I'm going to combine fractions. So I'm going to subtract 385, subtract 385. 25 converts to 225 over 9. That gives me a -60 over 9 equals B. Right? So by putting it together with M and with B, we can create an equation. C Celsius equals 5/9 F minus 160 over 9. Right? Now there is another equation that we have used in the past. C equals 5/9 F minus 32. Well, 160 over 9 is very close to 32. This is just by using observation. Not necessarily will observation get you exactly the right conversion equation, but it's darn well close enough. Alright, so that is it for this video. I do know that we went through some difficult problems, so if you need to rewind and rewatch, I encourage you to do so. Have any questions, please get a hold of me. So until next time, be seeing you.